Alright, so today we're going to talk about inverse functions. So we're going to find the inverse and we're going to do the horizontal line test of a function to determine whether we can find the inverse. So how are these two functions related? So I gave you two functions, f of x equals 2x and g of x equals 1/2 x. If I take f of g of x, I'm doing f of 1/2 x, which is equal to 2 times 1/2 x, which is x. If I do g of f of x, that's g of 2x, which is equal to 1/2 times 2x, which is equal to x. So what you should notice about this is the functions undo each other because they are opposite operations. So if I did f of 3, that would give me 6. If I did g of 6, that would give me 3. So in other words, g undoes function f and vice versa. So we call functions f and g inverses related to additive and multiplicative inverse here. So the inverse of a function, you kind of think about it like this. The domain of function f of x is going to be located right here. The range of that function, okay, is going to be located over here. We call that f of x. So I go from here to here. Well, now if I find the inverse, I'm taking the range and I'm making it the domain, and vice versa. The domain is going to become the range. So they switch spots. So will all functions have an inverse? If we interchange coordinates, will the inverse be a function? We know this will not occur all the time. When it does, however, the function does have an inverse. So some functions that won't have an inverse, okay, absolute value is really popular that you see. Anything with x squared in it is not going to have an inverse. So just keep that in mind. Because on the homework, they're going to ask you, does this function have an inverse? And you should be able to tell me based off of just the type of function that it is. So if a function has no two ordered pairs with different first coordinates and the same second coordinate, then the function is one-to-one and has an inverse. So an example here is the function one-to-one. If so, find the inverse. So when we're doing this, I got to make sure my domain goes to exactly one range. So my domain is 1, 5, and 6. My range is 6, 4, and 8. Well, 1 goes to 6, 5 goes to 4, 6 goes to 8. So we call that one-to-one. So it has an inverse because 1-to-1. Now the inverse, if you think about coordinates, would be 6, 1, 4, 5, 8, 6. So I switch the x and y coordinates to find the inverse. That's going to show up on the Hawks as well. Okay? Next one, if I look at the domain, I have 1, 5, and 6 again. My range is 6, 4, and 4. So 1 goes to 6, 5 goes to 4, 6 goes to 4. Should only wrote 1, 4. Notice it's not one-to-one anymore. So no inverse because not one-to-one. If our function was in the form of an equation, how would we determine whether it was one-to-one? So what I would do is I would graph it on Desmos and use horizontal line test. So we've done the vertical line test. Well, what is the horizontal line test? Well, the horizontal line test intersects the graph with a function f in more than one point, then f is one-to-one and has an inverse. So if I draw a bunch of horizontal lines, notice they only hit the graph once. So that means it has an inverse because it would pass the horizontal line test. However, the second one, if I draw a horizontal line, hits it more than once on one line, that fails the horizontal line test. So I would say no inverse. Okay? So you can always graph them on Desmos to double check and make sure and do the horizontal line test as well. So now, here's the main part of the Hawks. How are we going to find the inverse of a function that is an equation or a graph? Determine whether each function is 1 to 1. If so, find the inverse, then graph the function and its inverse simultaneously. So I pretty much did every example that does have an inverse. The only time you're really not going to have one is if it has x squared or absolute value, okay? So just keep that in mind. We talked about that earlier, but I feel like it's more beneficial for you guys to see the ones that do have inverses as opposed to the ones that don't, all right? So to find an inverse, right, this equation right now is saying y equals 3x plus 2. So to find an inverse, you switch the x and the y, and then you solve for y. So I'm going to subtract 2, and I'm going to divide by 3. My inverse, we represent that with a negative 1 after the x as the exponent, is x minus 2 divided by 3. Okay? Next one, negative 5 over 2x plus 2. Same thing. There is no absolute value or x squared in there. So I have an inverse. So I'm going to say x equals negative 5 over 2y plus 2. To solve this one, I'm going to multiply both sides by 2y plus 2. So I'm going to say 2y plus 2 times x equals negative 5. I'm going to then divide by x. So then I have 2y plus 2 equals negative 5 over x. I'm going to subtract 2. I'm going to divide everything by 2. So on this fraction part right here, when I divided it by 2, we do keep, change, flip. So we keep the top part, we change it from division to multiplication, and we flip the bottom fraction. And it was 2 over 1. Now we're going to make it 1 over 2. And then multiply to get my answer. And that's what I put, negative 5 over 2x. And then negative 2 divided by 2 is just negative 1, right? So my inverse is negative 5 over 2x minus 1. All right, so I tried to throw in some pretty tough examples here just to show you what you're going to see. We start off pretty basic, but then we get tougher and tougher. So this next one, same thing. I'm going to switch my x and y. I'm going to solve for y. So first thing I'm going to do is I'm going to subtract 4. Now, if you have a fraction exponent, you take both sides to the denominator power. So I'm going to say x minus 4 to the third equals y to the third minus 2. And that will get rid of that 1/3 over there. Okay? Going to add 2 now. So then I have x minus 4 to the third plus 2 equals y cubed. To get rid of an exponent, normally we would square root it, right? But this is not square, this is cube, so we cube root it. So we cube root everything over here. So I'm going to say the cube root of x minus 4 to the third plus 2 equals y. So my inverse is that answer, the cubed root of x minus 4 to the third plus 2. All right. This next one, I would say, is the toughest one that you will do on the Hawks. If you switch x and y, notice there's 2 y's that I plug in. So we're going to multiply both sides by y plus 2. Now here's what happens. You actually want to multiply the left side. So I get xy plus 2x equals negative y minus 3. That's how we get rid of that denominator. Now anything with a y in it, I want to move to the left side. Anything with just an x, I want to move to the right side. So I'm going to have xy plus y equals negative 3 minus 2x. Now what we do is we factor this side. So I'm going to say y is what I'm going to factor out. So I'm going to x plus 1 equals negative 3 minus 2x. I'm going to divide by x plus 1, divide by x plus 1. I get y equals negative 3 minus 2x over x plus 1. So that would be your answer. That's your inverse function. That one's probably the hardest one that you're going to see. The rest are fairly basic because once you get the hang of rational exponents, you kind of figure it all out. All right? So next one, I got to switch my x and my y. Now to get rid of a rational exponent, I told you take everything to the denominator. So that'd be x to the 5th, and now I have 2y minus 3. I'm going to add 3. I have x to the 5th plus 3 equals 2y. I'm going to divide by 2. Inverse equals x to the 5th plus 3 over 2. All right. Last one, same thing. Switching x and y. Going to add 5. We got x plus 5 equals 3 over the 5th root of y. Divide by 3. X plus 5 divided by 3 equals the 5th root of y. I'm going to take it to the 5th power. Take everything to the 5th power, so I get y equals x plus 5 divided by 3, all raised to the 5th to find my inverse. Okay? So that's how you do a lot of those problems. That's what you're mainly going to see on the Hawks is problems like that. However, if it has x squared or absolute value in it, then you're not going to have an inverse, okay? So it says sketch the graph f of -1 from the graph of f. All right, the easiest way to do this, guys, is to find some coordinates that you can use. So -3, -3, -1, -3. We can call that 1, 0. No, it's not quite there, but we'll call it 1, 0, and then we'll say 2, 3. Now, to find the inverse, I just switch x and y, and I graph it. So this is going to become 3, 2, which is going to go there. This is going to become 0, 1, which is going to go there. This is going to become -3, -1, which is going to go here. And then the last one's going to be -3, -3 still, which is going to go there. So if I graph it, the inverse looks something like that. So same way on this one. I just find some points that you can use. Because what you're going to do is you're going to switch the x and the y in order to graph it. So now I'm going to use, instead of 4, 3, I'm going to use 3, 4. 2, 2 is going to stay the same. It's going to be 1, 0, 0, -2, -3, -1. Sorry, -1, -3, -2, -4. So again, you switch the x and the y in order to graph the inverse if they make you graph it. All right? So inverse, kind of a recap, you switch x and y. If you have coordinates, if you're going to write the inverse function, you switch x and y and you solve for y, which we did a bunch of examples of those. Other than that, if you guys have any questions, please let me know. Your homework this time is going to be Hawks 3.7. 3.7. You're also going to have a quiz coming up, so make sure you're ready for that. Otherwise, we are good. I hope you guys have a great day.